What's up, kids? I'm here today to teach you what matrices are and also how to add, subtract, multiply matrices. So we're back in chapter 3, actually, the second half of chapter 3. Now, way back in, September or so, we learned about, let's see, chapter 3 was solving systems by substitution, elimination, and then you learned like 3 by 3 systems. Then we did linear optimization with using Desmos to find like optimal amounts of shirts and pants for companies, etc. Anyways, that was all in chapter 3. And back in chapter 3 is where matrices are found as well. So a little bit about a matrix. A matrix is just a rectangular array of numbers. It will look like this, right? 3, -2. They're spaced out so you can easily see, what the digit is. For instance, we know that's not -27 because of how spaced out it is. So -2 and a +7, each in their separate space. So 6 could go there, and let's say an 8 goes there. And so it's a rectangular array of numbers into rows and columns, right? They're a bracket. Matrices are bracketed, and what matrices are used for in the real world is like for a lot of coding, computer programming, how to do calculations super quickly on multiple pieces of information, and so solving equations, solving systems you can use matrices for. So there's a good amount of application in math that matrices have, and so I just want to teach you just a little bit about it. First of all, this is a matrix, and every matrix has a dimension, okay, a number of rows and columns. This particular dimension happens to be a 2 by 3 matrix. 2 rows and 3 columns. So the first number that you see is the number of rows. We can clearly see there are 2 horizontal rows. Rows are horizontal. And then there are 3 columns. Whoops. Yep. There are clearly 3 vertical columns. Okay, so this would be a 2 by 3 matrix. Okay, and so I'm just going to make another one up. Now, a matrix can be one number. Okay, the number 1, right, in a set of brackets, this is a matrix. This is a 1 by 1 matrix, 1 row, 1 column. Okay, you can have a 1 row matrix, right? 1, 2, 3. This would be a 1 by 3 matrix. You could have a column matrix, which is 6, 7, -4. You could have a 1 column matrix. This would be a 3 by 1 matrix. Okay, so a matrix is a rectangular array of numbers. All right, so sorry, I had to pause for a minute, so I lost my train of thought a little bit. But anyways, rows and columns, dimensions of a matrix. Let's talk about operations on matrices now. Super simple. Okay, starting with addition and subtraction. Okay, you are only allowed to add and subtract matrices that have identical dimension. Okay, identical dimension. That's the first thing I want you to write down. To add and subtract, you have to have identical dimension. And the reason why is dimension. Jeez, I bought a $30 stylus. It doesn't work very well. Sorry. Okay, anyways, identical dimension. So if you have a 2 by 2, let's say 2, 1, 3, 5. These are called, buddy, you got to stop moving so much. You're making Dad mess up. Sorry. Okay, anyways. 2, 1, 3, 5. That's a 2 by 2 matrix, rather. It's also called a square matrix. Same number of rows as columns is called a square matrix. If you were try to add it to, something like this, 1, 2, 6, a 1 by 3, like, how would you even know what went with what? I mean, I suppose you can make the argument that the 2 would go with this 1 and the 1 would go with this 2, but then what does the 6 go with? I mean, you can't just make up your own rules here. So the identical dimension rule for adding and subtracting. So if you have a 2 by 2, it would have to be added with another 2 by 2. -6, 5, 0, and 7. And if you added these together, you get another 2 by 2, and it's literally as easy as adding the elements that are in the same positions to one another. Okay, so -2, 2 plus a -6 is a -4. 1 plus 5 is 6. 3 plus 0 is still 3, and 5 plus 7 would be 12 there, leaving enough room in between the 3 and the 12 to show that they're in a different position. Okay, so subtraction works the same way. If you were to change this to a subtraction sign, you're doing the same exact thing. You're doing subtraction, right? And you just have to make sure, obviously, your signs stay legit, and you're just slowing down a little bit and making sure you don't mess this up. It's still super, super easy. You would have 2 minus a -6, and 2 minus a -6 is 8. 1 minus 5 is -4, top right element. Okay, -3 minus 0 is, 3 minus 0 is still 3. And 5 minus 7 is -2. Okay, so adding and subtraction, they have to be identical dimension, and you just literally add or subtract the elements that are in the same positions. That's true if they were 3 by 1 plus a 3 by 1, or whatever it might be. As long as they're identical dimension, you can add or subtract them. Now let's go to multiplication, because this is what's going to take longest and is definitely the most challenging. Okay, first of all, in multiplication, there's 2 things I want to show you here. Number 1 is, let's go to -1, 3, 5, another 2 by 2. There's something called scalar multiplication. Scalar multiplication is when you take a number times a matrix, and all you're doing, all right, this is called scalar multiplication. All you're doing is scaling the numbers up by this number right here. So there'll be a multiplication sign. That's a number, that's a matrix, and it's literally as easy as distributing that number to all elements of the matrix. So it'd be 6, -3, 9, 15. In other words, you're scaling up all the elements of that matrix by 3. It's called scalar multiplication. Okay. Then there's just a multiplication of a matrix times a matrix. Let me show you how that works for a minute. Okay. So let's see. Multiplication of matrices. So matrix multiplication. Okay. The rule here is the columns. Write this down. Turns out the matrices do not necessarily, it's not about the matrices having identical dimension when we're multiplying. The columns of the first, write this down, must be the same as the rows of the second. Okay, I'll show you what I mean, but that's our general rule for multiplying matrices together. So let's do a 2 by 2 times another 2 by 2. Okay, yes, they're identical, but that is not the rule for matrix multiplication. What we're looking at is the columns, which is this guy. Do the columns of the first matrix equal the rows of the second matrix? And since both of these are 2, this is possible to multiply these, and what is the resulting matrix is these numbers here, a 2 and another 2. So as it turns out, a 2 by 2 times another 2 by 2 is possible, and you will get a 2 by 2 that results from it. But you won't always have that happen, when we get into different dimension, and I'll show you what I mean by that. But first off, let's make up a 2 by 2 times a 2 by 2. So let's do 3, 4, 5, 6 times 7, 8, 9, 10. Okay? And we already know that the columns of the first matches the rows of the second, and the resulting matrix is going to be another 2 by 2. So what I do is I actually write out the resulting matrix and I put little blanks here, okay, to show to kind of to show that you know what's going to result is another 2 by 2. Okay, now this is not, here's what you don't do. You don't just multiply this 3 times this 7 and call it 21. That is not how you multiply matrices together. But here's what you do. I'm going to back this up. Okay. What you do is to find this element. This element is in the first row and the first column of our resulting matrix, right? First row, first column. So here's what you do. You combine the first row here with the first column here. Okay? And here's how you combine them. You take 3 times 7, okay? First element here, first element here. So what goes in this position is 3 times 7, and you add it to 4 times 9. Second element, 4 times 9. Okay, so 21 plus 36, 21 plus 36 is 57. 57 actually goes in that position right there. Okay, and that again was a matter of combining the first row with the first column, because that's the element we were trying to find. First row, first column. Let's keep doing this and you'll see how it works. Let's try to find the element in the first row and the second column of our matrix here. Okay, so what this would be doing is combining the first row here with the second column over here. Okay, so now it would be a matter of 3 times 8 and then adding it to 4 times 10, which is 24 plus 40, which is 64. Okay, now let's switch colors here and go blue. Okay, finding this element right here is now in the second row and the first column. So here we would combine the second row of our first matrix with the first column of our second matrix here. Okay, and what that would look like is that would be 5 times 7, and then you would add it to 6 times 9. Okay, notice first element, second element, second element. That's why they're paired together. 35 plus 54, 89. 89 goes there. Okay, and lastly, this element is in the second row and second column. So what you would do is you would combine the second row here with the second column here. And how that looks is 5 times 8, and then you'd add it to 6 times 10. 40 and 60. What's 40 plus 60, Carson? 100. Good job, buddy. Okay. So that's actually how you multiply matrices together. And here's why we need these numbers to match. Look, the columns of the first has to match the rows of the second, because here's the columns. The number of these numbers has to equal the number of these numbers going downward, so we have matches. The 3 went with the 7, the 4 went with the 9. Okay, for instance, watch this. Here's why you can't multiply like a 3 by 2 times a 3 by 2. Same exact dimension. You can't multiply these together. Watch what happens here. A 3 by 2 is 3 rows, 2 columns. Let's do this real quick. 6, 1, 7, 2, 8, 3. Okay, if you try to multiply that times another 3 by 2, which is let's go -1, 4, 2, 5, 9, 7. Okay, here's what happens. Like, you try to, first of all, what would even, let's assume maybe this was another, if you think you could, another 3 by 2. Oops, get back. If it was another 3 by 2, like, how would you, okay, this is first row, first column, I guess. So here's what you'd do, I guess. You would just try to combine the first row with the first column, and here's the problem with that. The 6 would go with the -1. The 1 would go with the 2. What goes with the 9? You don't have the proper number of numbers in this row. In other words, the columns of the first matrix did not equal the rows of the second matrix. Okay, so let's practice this for a minute. Okay, and then we'll do a couple more examples. Let's say we had a 2 by 1 times a 1 by 3. Would you be able to multiply these together, yes or no? The answer is yes, because these two numbers match one another, and the resulting matrix would actually be a 2 by 3, which is strange because neither of these are a 2 by 3, but when you multiply them together, you'd get a 2 by 3. I'll maybe show you how that works. Maybe we'll use those dimensions as an example, okay? And now here's the interesting part. If you took that same 1 by 3 and put it on the left, and that same 2 by 1 and put it on the right, and then you tried to multiply them together, these don't match anymore. Not possible. Which is really, really strange, because in numbers like 7 times 8 is the same thing as 8 times 7. Numbers are commutative. However, matrices are not. Matrix multiplication is not commutative. So we have to watch that. But let's take a 2 by 1 times a 1 by 3 for a minute. So 2 rows, 1 column would look like this, 8, 7. Okay. Now, one row, what was it? 1 row, 3 columns would be more of a horizontal thing. Let's take it times 6, -1, 4. Okay. I'm going to make this a little bit smaller for us. 6, -1, 4. Come on. All right. We already know we saw last page that we could do this. Okay, this is what the result of this is a 2 by 1 and a 1 by 3. The result of this is going to be a 2 by 3. Okay, so the result of this is going to be a 2 by 3. I'm going to write this out. 2 rows, 3 columns. So 1, 2, just like that. Okay, now let's do this. This will go quite a bit quicker. To find this element, this is first row, first column. I take the first row and combine it with the first column. And I don't even have multiple numbers here. I just have one number each in each of the row and column. So 8 times 6, which is 48. Okay, let's switch. Let's not even go in order. Let's go. Let's find this one right here. This is the second row, second column. All right, second row, second column. -7 goes there. Okay, sorry, bad handwriting. That's a -7. Okay, let's do this one. Second row, third column. Combine the second row here with the third column there, you'd get 28. Okay, let's do this one. This is in the first row and second column. Okay, we combine the first row here with the second column there, you get -8. May as well finish this. I'm going to go in the same color. Oops, back that up. -8. Okay, this element right here is in the first row and the third column, so that's 8 times 4, which is 32. This element right here is in the second row and the first column. Okay, so second row, first column, 42. That's how you matrix multiply, and that's how we arrive at a 2 by 3 rather. Okay. You'll practice this multiplication here on your worksheet tomorrow, but essentially, like, if you take lastly, before I let you go for the day, if you take a 1 by 3 and you multiply it times a 3 by 1, can you do it? The answer is yes, because these match up. What's your resulting matrix going to be? It's going to be a 1 by 1. That's interesting that they're only going to have one element there, but watch this. I'm going to take the same 3 by 1 and write it over here, and the same 1 by 3 and write it over here. Now, can we multiply it? The answer is yes, because these are the same number, and the resulting matrix is going to be a 3 by 3. So super interesting how you take those two matrices, you swap them, right? One on the left, one on the right, and just switch spots with each other, and you'll still be able to multiply them, but you'll arrive at a completely different matrix. And so what I want you to try and do is to end this video is I want you to take 1, 2, 3. There's a matrix. And then 4, 5, 6. There's a matrix. Okay? Multiply them when this is the left one, this is the right one, and then switch them. Make this the left one and this the right one. Okay? And watch what happens to your result. In this particular, the way it's set up right now, you'll get a 1 by 1. If you switch spots, if you switch their spots, you'll arrive at a 3 by 3 when you multiply them together. So pretty cool how that works. Anyways, I want you to try that on your own. You'll have homework that comes out tomorrow. We'll talk to you soon. Good job today.